Welcome students to our video notes lesson for section 2.6 from unit 2, where in this lesson we're going to learn the third and final method for solving a quadratic equation. And that third and final method is using a formula that we refer to as the quadratic formula. So it might help to remember that a quadratic equation is an equation that looks something kind of like this, but more specifically an equation where the highest power of x is 2. The highest exponent is 2. So you'll notice in our different problems in our lesson today that each of our equations has an x squared term. Okay, now before we get into the quadratic formula, I'd like to revisit what we learned back in section 2.5 on completing the square. Now, when we learned how to do this lesson, we learned how to do this only when the a value is 1. So there's something that we're going to have to do when the a value is not 1. One additional step that we'll have to do in order to solve by completing the square. And that additional step in this case will be to divide both sides by the a value. Now remember, when I say the a value, I'm referring to the number that's being multiplied to the x squared term. So in this case, the a value is 2. So in fact, a is 2 in this case. The b value would be 11, and the c value would be -5. So b is always the number being multiplied to the x term, and the c is always the constant that has no x. Okay, so in this case, we need to divide both sides by 2. Now, when you divide the left side by 2, you have to be careful to divide everything on that side by 2. And then 0 divided by 2 is just 0. So here I would have 1x squared minus 11 halves x minus 5 halves. And that still equals 0 because 0 divided by anything is just 0. So now I have changed the a value to be 1. I've changed the b value to be 11 over 2. And I've changed the c value to be -5 over 2. So now I'm going to do the completing the square process. So then we move the c value to the other side. So I'm going to add the 5 halves to the other side so that I can clear up some space to complete my square. So I'm going to try to find the perfect number that I could plug in here that will allow me to eventually factor the left side into a perfect square. So that was our 2.5 lesson. That's where we learned that we're supposed to divide b by 2 and square it. So in this case, that would be -11 halves. I need to divide that by 2, which is the same thing as multiplying by 1/2. So that would become -11 over 4. So that's the dividing by 2 part. That was this part. And then I'm supposed to take that result and square it. So then that's taking my half of b and then squaring it. So when I take half of b and square it, I end up with 121 over 16. That is my half of b squared. So I'm going to add 121 over 16 to the left side. But remember, I got to keep that equation balanced. So I got to add 121 over 16 to the right side as well. So then I'm going to have to do some common denominator stuff over on the right side so I can make that into one fraction. So what I'm going to do with my 5 halves is multiply by 8 over 8, because that will allow me to have a common denominator of 16. So my 5 halves will turn into 40 over 16, and now I can add that to 121 over 16, and then I end up getting 161 over 16 on this right-hand side. Now on the left-hand side, I have a perfect square, and when we create these perfect squares, our factor, this number here, is always half of b, or it's always the square root of c, however you want to think of it. But in this case, it's going to be 11 over 4. And then that is squared because 11 over 4 plus 11 over 4 would equal 11 over 2. And then 11 over 4 times 11 over 4 would be 121 over 16. So this is all equal to 161 all over 16. Now it's at a point where I can just go ahead and square root both sides. So when I do that, I end up with just x minus 11 over 4 on the left-hand side. I end up with plus or minus the square root of 161 over 4 on the right-hand side. So whenever we have like a large value inside a square root like this, we should look to see if possibly it simplifies. So I'm going to do a little scratch work off to the left over here. So I know that 161, if I divided that by 7, would equal 23. Or I know that 7 times 23 equals 161. Well, both of these are prime numbers, so I can't factor them into anything else. And since there's only one of each factor, I don't have two of the same factor, that means this square root cannot be simplified. But we should always check. Okay, so then what I would have to do last is just add 11 over 4 to both sides to get x by itself. So then on the left-hand side, those would add to 0, so I would just have x. And then on the right-hand side, we can combine these because they have a common denominator, so we can just add 11 and subtract 11, or add the square root of 161 or subtract the square root of 161 from 11, and all of that is being divided by 4. So you might be thinking, oh my goodness, like, do we have to do that on a test or quiz? And the answer is yes and no. If you want to, you can, but you don't have to, because what we can do, what we're about to do, is the same exact process, but for A, B, and C. So yes, because the quadratic formula basically is the solution to completing the square, but no, because if you memorize the formula, then you don't actually have to complete the square. Okay, so now we're going to solve the following equation, where we're going to leave A, B, and C in the equation as A, B, and C, but we're going to recognize that they represent numbers, okay? They're letters in here because they're just general numbers. So in our last example, A was 2, B was 11, and C was -5. So those are typically numbers. But what we're going to try to do here is leave them as letters so that my solution is basically a formula. So I'm going to follow the same steps that we just did up here for completing the square. We started by dividing both sides by A. We moved this C value to the other side. We then completed the square by dividing B by 2 and squaring it. We then added that value to both sides. That was the 121 over 16. We combined our fractions into a common denominator on the right side. We factored our perfect square on the left side. And then from there, we square rooted both sides. So those same steps we're going to follow over here. So I'm going to start by dividing both sides by A. Oh, and I noticed there's a typo here. That should say plus. Sorry, it should be ax squared plus bx plus c. So we're going to divide both sides by A. So on the left side, that means each individual term has to get divided by A. So on the left side, I'd have x squared plus b over ax plus c over a. And then 0 divided by anything is still 0. So 0 divided by A representing some number, is just 0. So now I get to a point where my A value is 1. This is what allows me to complete the square. But I need to move the C over A to the other side in order to make room on the left for me to complete this square. So I'm going to subtract the C over A to the other side, so that cancels it from the left. So now I have on the left x squared plus b over ax plus blank. I'm going to fill that in a moment. And then equals negative c over a on the right-hand side. Okay, so now it's set up for me to go ahead and complete the square. What that means is I can now take the middle term, which is b over a. I can divide it by 2, which is the same thing as multiplying it by 1/2. And then that gives me b over 2a. Then I square that. So I square the result. So I would take that b over 2a and square it. And then that ends up being b squared, so I square the b, over 4, because I square the 2, and then a squared, because I also square the a. The reason I was able to just square everything is because everything is connected either through division or multiplication. So this is what I got when I completed the square. I got b squared over 4a squared. So that tells me that's what I need to add to both sides in order to be able to factor this left side into a perfect square. But before I do that, I'm going to need to get some common denominator over here so that I can combine this into one fraction. So the negative c over a, I'm going to need to multiply by 4a over 4a, because then that will give me a 4a squared in the denominator, which is what the other fraction had in its denominator, which will allow me to then add them together. So then the negative c over a, when I multiply it by 4a over 4a, gives me negative 4ac over 4a squared. And now I can go ahead and add that to the b squared over 4a squared, which is the thing that I'm adding to both sides. And then when I do, I end up getting b squared minus 4ac all over 4a squared. So this is what I have on the right-hand side. And then meanwhile, over here on the left-hand side, I have a perfect square, x squared plus b over ax plus b squared over 4a squared. This can now factor into a perfect square of x plus b over 2a, because this is always half of the middle term. Is one way to think about it. Or you can think about it as the square root of the last term. But that's what that will be when I factor it into a perfect square. And that's because b over 2a plus b over 2a would become b over a. And b over 2a times b over 2a would become b squared over 4a squared. So that's the factor. And it's equal to this. So I'm going to write all of that down here. So I have x plus b over 2a squared is equal to b squared minus 4ac all over 4a squared. It is now set up so that I can go ahead and square root both sides. So after I complete the square, I can then square root both sides. So on the left side, the square root and the square cancel, and I would just have x plus b over 2a. On the right side, I would have plus and minus. And then for the numerator, since there's a subtraction, I can't split the square root. I just have to keep all of that under the square root. But for the denominator, since the 4 and the a squared are connected through multiplication, I can go ahead and square root them separately. So the square root of 4 is 2. The square root of a squared is a. Okay, so this is what I have on the right side. And then now I just need to solve for x by subtracting the b over 2a to the other side. So now on the left-hand side, x is by itself. And I can go ahead and combine these fractions because they have a common denominator. So I just add the numerator. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula. Okay, the quadratic formula came about by solving a quadratic equation, ax squared plus bx plus c equaling 0, by completing the square. That's basically how this formula came about, was by completing the square. But since I completed the square with a, b, and c plugged in, what I basically did was solve any quadratic equation ever, because I have the solution right here in general form. So what do I use this formula for? I use this formula for when I want to solve a quadratic equation. So when I'm solving something like this. Something times x squared plus something times x plus something. I notice I need to get 0 on one side, so that's how this started. And then I can just identify whatever a, b, and c are. Whatever those numbers are, I can identify them and just plug them in to this formula wherever a, b, and c are. And that's basically the same thing as solving this by completing the square. It's just that it's already been done, and I can just use this formula. So that's basically the third and final way of solving a quadratic. So let's take a look at one example here. So the formula is negative b plus or minus, negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to use that formula in this example. So in this example, I have a is 3, b is 15, and c is negative 1. So a is 3, b is 15, and c is negative 1. So you might want to start by making sure one side is equal to 0, and then identifying what a, b, and c are. Okay? And then plug them into the formula and simplify. So I start by negative b. So in this case, that would be negative 15 plus or minus the square root of, and then I have to square the b right here. So that would be, I'll just write it right now as 15 squared. And then I have to do 4 times a times c, which is negative 1. And then all of that is divided by 2 times a. So right now, I just have like a bunch of numbers that I'm going to need to simplify. So this would be negative 15 plus or minus the square root of, and then it would be good here to simplify the inside. So 15 squared is 225. 4 times 3 times negative 1 would be negative 12. And then 2 times 3 is 6. So then that brings me to, I'm going to end up adding these together, because when you're subtracting a negative, you end up adding, and I get 237 in that square root, and that's all being divided by 6. Now you might mistakenly think, well, hey, can't I cancel a 3 from both the 15 and the 6? And the answer is no. You can't cancel a 3 from the 15 and the 6 because of this plus and minus. This 15 is being added to something else and subtracted by something else, so we can't cancel it. But what we could do is see if the square root part can be simplified a little bit. So we would need to check and see if we can simplify the square root of 237. So I'm going to do some like side scratch work over here. So 237 can divide by 3. When I divide by 3, I get 79. But these are both prime numbers, and neither one of them are repeated factors, so this square root of 237 cannot simplify any further, so I can't really simplify this expression any further. So that would be our final answer, solving using the quadratic formula. Now, because we're learning this for the first time, I want to show you what these numbers are. So first of all, I want to point out that this would be our solution in what we call exact form, because this is the answer that has not been rounded. But I would like to show you the approximate form, and I would like you to also find the decimal approximate form on your homework, just because you're learning this for the first time and you need to see what these values are. So the decimal approximation is found by actually figuring out what the square root of 237 is with a calculator, adding that to negative 15 and then dividing by 6, and then also doing the one where you subtract 15 minus the square root of 237 all divided by 6. So with a calculator, we can see that the square root of 237 is approximately, so not exactly, but approximately 15.4. So that's the approximate, right? That's what this squiggly means. So then these values are approximately equal to negative 15 plus 15.4 all over 6, and, sorry, that's negative 15, and then negative 15 minus 15.4 all over 6. And then this number would turn into 0.4 over 6, which is approximately equal to 0.067. So that's one approximate value. And then this one would equal negative 30.4 over 6, which is approximately equal to negative 5.067. So these would be the approximations of these two numbers here. So these are the numbers in exact form. These are roughly what they are. So you can kind of get an idea of what x would have to be. Here it's somewhere between 0 and 1. Here it's somewhere between -5 and -6. Okay, so now what I want us to look at in example 2 is some comparisons between the methods we have used, completing the square as one, and the method we now know, just so you can kind of see the pros and cons to each one. So number 2 is like a standard 2.5 question, a very simple one to complete the square by. So I want us to kind of walk through that. So we're going to move the 11 to the other side because we're just trying to basically get to a point where it's like something squared equals a number. But in order to get that something squared, I need to get this out of my way. Then I'm going to complete the square. So that's the next part is CTS, complete the square. So I take 4, divide it by 2, square that to get 4. So I'm going to add 4 to both sides. So I get x squared plus 4x plus 4 on the left, and then over here on the right I would have -7. Now on the left I can factor it into a perfect square because 2 plus 2 is 4 and 2 times 2 is 4, and then I just have the -7 on the right hand side, and then I would square root both sides. So I get x plus 2 is equal to plus or minus I times the square root of 7. And then all I have to do from there is just subtract the 2. So this is one of those completing the square examples that was not too difficult to solve. And we would write our final answers like this, -2 plus or minus I root 7. So that's the method when we complete the square. Now using the quadratic formula, instead we make sure there's a 0 on one side, so check. We identify A, B, and C. So A is 1, B is 4, and C is 11. And then we plug them into the formula. So this would be -4 plus or minus the square root of B squared minus 4 times A times C all over 2A. So here I have my quadratic formula. It's just a matter of simplifying from here. So this would be 16 minus 44 all over 2. And that would end up being -28 inside my square root. So you may notice, well, I haven't quite gotten down to this simplified form yet. So that's the part about quadratic formula that can be challenging, is the simplifying. So first we'd have to start with this square root of -28. So maybe I'll just think of it as 28 first. So I have a 4 and a 7. 4 times 7 is 28. So when I square root those two numbers, I get a 2 and then just a square root 7. But because of the negative there, because of that, I also have -1. Square root of -1, which is I. So what this turns into when I simplify the square root of -28 is I end up with -4 plus or minus. I have the 2 that I brought out, the I, that is the square root of -1, times the square root of 7, and then all of that is over 2. We're almost done, but there is a common factor in the numerator and denominator, and so I will need to factor out a GCF. So I have a GCF of 2 in the numerator that I would need to factor out. So I'd take out the 2, and then the 4 would turn into a -2. This 2 would divide away, so I would just be left with I square root 7, and then all of that is being divided by 2, and then I could cancel those common factors of 2. And then I would end up with -2 plus or minus I square root 7. So we get the same answer, but you might be noticing that in this particular scenario, there was much less simplifying to do at the end of completing the square. So I want you guys to list in your mind the pros and cons to each method, because there are some pros to the quadratic formula, right? X is already solved for, and you just have to simplify, things like that. But I want you to list this for yourself, and I'll be looking, when I come to stamp this, I'll be looking to see what you guys listed here. So the next thing I want to do to contrast is solving by factoring in the zero product property as well as the quadratic formula. So same equation again, but on this side we're going to try to factor it so that we can use the zero product property. So nice thing is we already have 0 on one side. So if I can just turn this into something times something equals 0, then this could be like the zero product property, right? A times B equals 0. If I have one thing times another thing equaling 0, then I know this might be 0 or that might be 0. So that's kind of what the quick recap of the zero product property is. Okay, so I'm going to try to factor this one on the left. So the way we learned this back in Unit 1 was by guessing and checking. So I know that this part times that part has to equal 3x squared. So I'm going to start out with 3x and x. And then I know that this part and this part have to multiply to negative 14. So there's a lot of possibilities there. I could maybe use negative 1 and 14, or 1 and negative 14, or 2 and 7, or negative 2 and 7. Oh, sorry, 2 and negative 7, or negative 2 and 7. Yeah, those are my options. So I think I'm going to start with like 2 and 7 just to see what happens. So if I do 2 here and 7 there, and I'll make this one negative and this one positive. So if I get those factors, then I distribute out, I'd have 3x squared minus 21x plus 2x. Okay, so I can see that that one won't work. So I'm going to try maybe switching the 7 and the 2. So I'll put the 7 here and the 2 here. And then I notice that I would have a negative 6x plus 7x. So that's not going to work either. So maybe I'll try the 14 and 1. And maybe I'll put the 14 here so that I don't end up multiplying 3 and 14. So if I do 3 times 1 and then negative 14 times 1, here we go. So I have 3x squared plus 3x when I do that one, minus 14x when I do those, and then minus 14. I notice that these right here will add to negative 11. So that tells me I factored correctly. That tells me that if I multiply 3x minus 14 together with x plus 1, I will get 3x squared minus 11x minus 14. So then I know that this is my A and that is my B, because that times that will equal 0. Because all along this expression equaled 0, I figured out what multiplies together to equal this expression. That means these factors multiply to 0. That means either 3x minus 14 is 0 or x plus 1 is 0. This one here would tell me that, wait for it, x is equal to 14 thirds. And then this one here would tell me that x is negative 1. So these are the answers I got by having to do some guessing and checking to factor and then setting each factor to 0. Now here, using the quadratic formula, again, I just have to start by identifying a, b, and c. So a is 3, b is negative 11, and c is negative 14. And then I would just plug them into the formula. So negative b would be negative 11, and then plus or minus the square root of b squared minus 4ac all over 2a. So x is already solved for. These are my answers. I just have to simplify that a little bit. So I get positive 11 plus or minus the square root of 121 minus, and then 4 times 3 times negative 14 is negative 168 all over 6. So then that's 11 plus or minus the square root of, and then these actually add together because I'm subtracting a negative, and I get 289 inside that square root. And 289 happens to be a perfect square. The square root of 289 is equal to 17. So then I end up getting 11 plus or minus 17 all over 6. And so that's either 11 plus 17 over 6, or that's 11 minus 17 over 6. And so this one would be 28 over 6, and then this one would be negative 6 over 6. So this one I can reduce because I can divide both by 2. So here I get 14 over 3, and then here I get negative 1. So again, I get the same answers, right? It's the same equation, 14 thirds and negative 1, by just plugging in a, b, and c into the formula and then doing some simplifying. So both of the options here have pros and cons to them. And I would like you to kind of consider what were the pros and cons of factoring, right? I'd like you to list them out. Factoring pros and cons. And then what were the pros and cons of the quadratic formula? So I'll be looking for this again when I'm back and I'm stamping your notes. I'll be looking for this pros and cons list for each method. Okay, so then the last thing we're going to do is just use our knowledge now to find x and y intercepts of these types of functions. So remember, a function is when you have two variables. We've got x and y, right? And it's a quadratic function because the highest power of x is 2. And now we're going to use our skills to find intercepts. So just as a reminder, the x-intercept is when you plug in 0 for y and solve for x. So it's like number, comma, 0. So we'll start with that for part A. We'll start with the x-intercepts. So the x-intercept is when I plug in 0 for y and solve for x. So I have a quadratic equation that's set equal to 0, which is perfect for either using zero product property or the quadratic formula. Now the instructions here tell us to use each method exactly once. So I'm going to see if this one possibly factors. I think I'm going to use factoring if it works. So I'm going to see if I can find two things that multiply to equal this expression. So I'm going to try 2x and x to get my 2x squared. And then for 33, I'm going to do 3 and 11. So when I do 3 and 11 and I FOIL it out, I'm going to make this one negative and this one positive. I get 2x squared minus 22x plus 3x. I realize, nope, that's not going to work because that's going to add to negative 19, not negative 5. So let's scratch that. Let me try flip-flopping these. Let me try putting the 3 here and the 11 there. So now I have 2x squared minus 6x and then plus 11x. That's closer. That adds to 5x. So now I realize all I really need to do now is switch the signs. And then make this one negative and that one positive. So when I FOIL them, I would have positive 6x and negative 11x. That would add to negative 5. And then negative 11 times 3 would give me the negative 33. So I can see that 2x minus 11 times x plus 3 does in fact equal this expression. So I know that 0 equals 2x minus 11 times x plus 3 because 0 equaled this. And these are the two things that multiply to equal that. So I know that I have two quantities multiplying together to be 0. So I know that one of them has to be 0. So I'm going to solve each here. So I get 1 is 11 over 2. One solution is 11 over 2. And the second solution is negative 3. So these would be my x-intercepts. I'll write them over here. So my x-intercepts, I always want you to write intercepts as ordered pairs. So I have one of them at negative 3, 0, and I have the other one at 11 halves, comma 0. And if you want, you can write that as 5.5 or 5.5. Either way is fine for this number. Okay, then for the y-intercept, that's when you plug in 0 for x and evaluate, because in these equations, y is already alone. I don't have to solve for it. It's already solved for. I just need to simplify. So for the y-intercept, I would have y is equal to, and then wherever there's an x, I would swap it with a 0. So 2 times 0 squared minus 5 times 0 minus 33. And then this would just be 0 minus 33. So the y-intercept just ends up equaling negative 33. So when I write that as an ordered pair, I'm going to put 0 for x because that's what I plugged in for x, right? So this is the value of y when x is 0. So these are my x-intercepts, and this one here is my y-intercept. Now what I want you to do is to go to desmos.com and just type in this equation to see if in fact the graph hits the x-axis at -3 and 5.5, and if it hits the y-axis at -33. Okay, so here's my equation. Notice I'm not seeing the whole graph, so maybe I will zoom out a little bit and maybe lift it up a little bit here so I can see. Okay, so here's where it's hitting the y-axis, and I can see that that really is in fact at 0, -33. And then I can see this intercept of -3 and then the other one of 5.5 or 5.5. So I can look at these points to check that I found the correct x and y intercepts of this quadratic equation. Also, make a note of the fact that this graph looks kind of like a U, right? It looks kind of like a U. I want you to kind of make note of that, and let's write that on our outline. So it'd be good if you could kind of sketch a little shape of that graph over here. So it had one intercept at -3, another one at 5.5, and then a y-intercept way down here at -33, and it kind of looked like something like that. So just kind of a brief sketch based on what you saw on Desmos. Okay, so here is another way that you might see quadratic equations expressed. This one has like a perfect square sort of embedded in it, and then just something else being added or subtracted to it. So this kind of lends itself nicely to completing the square, or to square rooting both sides, I should say. The square is already completed, right? It already has the perfect square right there. All you would need to do would be to isolate the square so that you could square root both sides. So I would, well, let me back up. So for the x-intercept, I plug in 0 for y, right? This is number, comma 0. So I'd plug in 0 for y. And then I want to solve for x. So because I already have a perfect square in my equation, it lends itself nicely to just square rooting both sides, but it helps to add the number to the other side so that I can square root both sides. So then I'd have, but just don't forget the plus and minus. Plus and minus the square root of 8. Meanwhile, on the right-hand side, the square root and the square cancel out. And then I would just need to subtract 2 to my other side. So I can see that my x-intercepts would be -2 plus or minus the square root of 8. And then I do want you to simplify radicals if you can. And since I know that 8 can break into 2 and 4, and I can square root the 4, this would become, the square root of 8 would become 2 rad 2. So this is -2 plus or minus 2 square root 2. So let's get a decimal approximation for this. So these are my answers in exact form. I'm going to put comma 0, right? X-intercept is number, comma 0. So these are my answer in exact form. But to check our answer, it's going to help us to get a decimal approximation. So I'm going to figure out a decimal value for the square root of 2. So the calculator says it's approximately equal to 1.414. So then this would equal -2 plus 2.828. And then that is equal to 0.828. So we're saying that that's one of the intercepts. And then the other one is when I subtract 2 times 1.414. So that's -2 minus 2.828. And then that would be -4.828. So these would be the decimal approximation for my x-intercepts so that I can check and see if I did them right when I look at the graph on Desmos. But this is how I would want you to write your answer, would be in exact form. Now, I'd like you guys to go ahead and find the y-intercept for this one. So we still need to find that. I want you to find the y-intercept and check with Desmos. And then I want you, for this last one, to find both x and y-intercepts. I want you to use the quadratic formula for this one just to practice. And then I want you to check with Desmos. And I'll see you in class to give you those answers. See you then. Bye.